Hello guys, we did a read at the last time. Here's the problem. You can be good by just reading a post or by reading a book. That's just the one step you have to make if you want to get process. Here's the second step. For this video, in this video, I will try to implement the whole process, or I will try to, make this scene, GAN, image to image translation, happen. So to make it happen, the first thing we will try to do is to copy all those codes. And we will copy all those codes to our Jupyter notebook or in a single file. Since we have copied all those codes into our Jupyter notebook, now we can do some experiments or try to get some ideas about the data we are using. And we're gonna call the experiment data experiment. And the second one, it should be training experiment. Before we download any dataset, let's just run those codes, see if we can, if we have all those libraries that we need installed on our computer. No, we don't have the Keras installed, so I'm going to install it. Okay, we still get some errors in here. It is said no module lambda 0. Okay, if we run this again after we installed the 0, it will say no such file or directory maps train. Since we have all our library installed, now we can try to download the datasets from the network. Alright, we have downloaded the datasets. Now we should put all those images to our project folder or to our repository folder. Okay, since we already have the dataset under our directory, now we can run all those processes now. Okay, here we go. After we load the npz arrows, we could say the pictures like this. How about the source image's shape? From this, we can say we got 1096 images, and for each image, it has the pixels of 256 times 256, and it's RGB images. Now let's try to do the training process. We define the discriminator. Finally, we define the training process. If I run this block of code, if I run this, it will start to train all those stuff. I need to change something. I'll make the epochs much smaller. For example, I would just do 2 times of training. I just want to say if the code was working for us. I just want to say if the code works for us. Okay, here's the problem. Node real samples is not defined. Okay, let's do this again. Okay, here's the problem. What value error in this function or in this layer with padding model sim, even kernel sizes are not supported with kernel. You can set kernel size to an odd number. Okay, that should be a problem because as we can see here, we got a lot of padding elements which has the value of sim. Okay, that can be a serious problem for us if we don't solve if we cannot solve that. Yeah, I'll just remove the padding stuff in there. Now let's run this again. I think the problem isn't about the sim parameter, but it relates to the kernel size. Kernel size, an integer or tuple of a single integer, specifying the length of the 1D convolution window. So instead of a kernel size of an even size, we need to change all of those stuff. For example, 4 to 4 to something like 3 to 3. We will try to do that, or 5 to 5. It's not that complicated. We'll change the 4 to 4 to 3 to 3. Alright, as we can say, here comes the training. We did it. We just made some changes to let the training continue. So glad we are able to solve the real problem instead of just reading the papers or tutorials. Okay, suddenly I just realized one problem here. Even if we set the epochs to 2, this training will still take, I guess, 2 times of 1000 times of training. It will iterate through those images from the first picture to the 1000th picture. It's quite a long time, since you can see here is my speed about the training. It's quite slow because I am using the CPU instead of the GPU, because you know the CUDA is not an open source software or driver. The language, it is not an open source driver, so it can be difficult to use Python to handle the GPU drivers. Okay, since he is in training, we will go to this tutorial and copy some codes from it. How to translate images with a pixel to pixel model. You can use this, but I will not. I don't think that's a good idea to use this code, because it will use the existing image at our dataset. But in real life, we will never use the same image in our dataset. We will use a quite new image. Okay, let's just copy this code. And put it in here. We need to have a function to load an image. Then we not load the model. We generate the image from that source, and that's all. I'm going to call this predict or prediction experiment. Now all we have to do is wait for the training finish. Okay, finally the training just stopped, because I can see it from this stuff. But here's the problem. At the end of this training, you won't see any notification that indicates you saved the model. So where's the problem? Here you can see that only the epochs equal to 0, 10, or 100. The model will use the summarize performance function, and the summarize performance function will save the generator model. So now we have to manually save our model. Okay, saved. We can have a look at the image we just saved. It was totally insane. I cannot say anything from this. I guess it just couldn't work by doing this level of training. But we don't have that computing resources, so we'll just forget about it. Let's just do the prediction with some new images. Okay, we'll say dot maps train. I'll use the second GPG file. Let's do this. Unable to open file. Okay, because the model has a len of this, we should change the code according to the model len. Here we go, let's do this again. This function will only show you the results. I don't know why, but we just cannot print out the original image. Okay, finally I just solved this problem. I found that if you want to node the raw image, you have to use the Keras preprocessing.img dot node image function. Node img. Node img. It is different than the node image. It's two different methods. Then the pyplot.subplot, the first parameter is the meaning about how many rows you want to plot. Here we got 2 rows, the first row and the second row. And the second parameter, it means how many clones you want. Here we only get 1 clone. And the last parameter means the index of that subplot, the first one and the second one. Above it is the source image, and in the bottom it is the image that we generated from the model that we have trained. From this group, we can say it clearly that it doesn't work, at least in this level of training. It cannot work. I was wondering if we could use TensorFlow instead of the Tornado backend. So I'm going to name this notebook the THEANO. Okay, I'm going to name this notebook THEANO. Then I'll copy this one and name it to TensorFlow. Then I'll have to change the kernel size from 3 to 4. Then I will have to go to another Linux or system to do the test with TensorFlow GPU supported. So maybe later in that video you won't hear my voice. You won't be able to hear my voice because I won't record my voice at that machine. Anyway, whatever you say later, it is the result of this video. I hope you enjoy it, and I will see you in the next video. Bye. Alright, now we are in a new system, and from here we can say the TensorFlow key. We are now using the TensorFlow backend. Then we load our data and try to do something about it. Just keep running those code. From here you can see that this algorithm or the TensorFlow is indeed are using the GPU, because we got nothing left in, so it is using our GPU. For this case, I'm going to set the n epochs to 10, and I'm going to run this model or run this training for 1 night, and we will see the final result in the end of this video. Good luck. Okay, sorry about this. I can say here's the problem. The GPU I got is too narrow, so we cannot do this at my local machine because we need a larger GPU than this. But at least we know if we run this when the whole model training process on CPU